This conference will now be recorded.
So today's session we are discussing about Docker. Docker is like a next level of virtualization. Next level of virtualization we are doing in Docker. So mainly we have to tell about the container. So we are going to create something called container. Docker is a tool for creating containers. So what is the meaning of container means? We know that we are using servers and we will install operating system in the server. So every company uses physical servers called host machine, and in the host computer it is having hardware, and above that they will install the operating system. So generally previously sometimes before, every company they buy one server and they will install hardware means processor, memory, storage, network, everything is there. So they will install the operating system, they will install. But now when they check they are buying a server with so much configuration. Maybe they are using 128 GB RAM and just 8 CPU. So they are, example, they are buying a server like this. But when they calculate so they will install the application, they will install. So they will be using for installing web server or application servers and all they are using. But when they check the utilization of the server, so they want to check how much load they are using. So they can understand they are, if they 10-year 20-year before, what they do, they will use physical server. So we are going to tell about three physical server we are using some 20 years before. Every servers are called physical servers. They will buy one server and they will install operating system. But after that, what they do, they will buy one server and they will install multiple operating system, they will install. So what is the main advantage of this? The cost. So they can fully utilize your server. There are many advantages are there. Automation, all the things are there, but main advantage is, one advantage is cost. So in the difference of this virtual machine, we are going to create virtual machines. We are going to create. So in the case of virtual machine, what we do, above the hardware, we will buy one server. Companies are buying one server hardware, and they will install a hypervisor software. Hypervisor is a software. It is helping for creating virtual machine. Hypervisor is different hypervisors are there. So they can use VMware, Hyper-V, Linux KVM. This all we are using. So mainly advantage is because previously we use a physical server. Now we are not utilizing the full server potential. We are not using, because now somebody will tell, no, Einstein there he is using his brain only. He is using 15% or something he use. Similarly, this server also we are just telling some example. So like that, this server we are not fully utilizing. So that is the reason we are one server. You can install multiple operating system. You can install multiple virtual machine. You can create. So that is the way we are using virtual machine. So that is a completely new, entirely complete virtual machines you can create. But now the next level is we are using containers. Container is like a VM, but here there is a difference is there. So we are going to create some containers. We are creating. So container, what they do, it is called operating system level virtualization. So we are showing three things. First is a physical server. Physical server means one server we will install one operating system, and virtual machine they will install multiple operating system. And container means we have above the hardware, so they will install the OS directly, operating system they will install. Mainly this is working on containers. We used to create on Linux or Unix, but now it is possible in Windows also. They started they can create Windows containers, and they will use some container engine they will install. So container engine is a software. It is using for creating the containers. For example, in the second way, you can see that we are using hypervisor, but in the third case, we are creating container engine. We are creating. So container engine X. This is a Docker. Is what it is. Docker is a container engine to create the container. So this is containers. Container 1, container 2, container 3. We are creating. But here we are creating VM1, VM2, VM3, and you are creating. So here in the case of container, what they do, they will share the operating system. They will share operating system kernel. They are sharing. So that is the way it will be working. Kernel they are sharing, but every container having its own file system, and every IP address, everything is different. So that is the different way of container and virtual machine. Container is called operating system level virtualization. So virtual machine means the physical hardware they are virtualizing. So that is the way container is working. So Docker is a tool or engine for creating the container. So now why we are calling it as container? So we are calling this as a container. So what is the meaning of container? We know. So just we know when we want to do transporting of any item, we want to send some item from one place to another place, ship or some trucks, and we use containers. So the picture of a container is this is a container. So you can see that in the ship, they are sending it to another place. So Docker is like a ship. It will be helping to create the container. It will be helping to create and moving the container. So why this name is coming means uh, because these containers are very portable. So what they are telling, suppose so previously developers developing the application. So they are developing Java application. They are developing application. They are develop application. So the application may be Java or PHP. For example, they use Java, PHP, some application they are using. So they need, whenever they create an application, they need some dependencies. Dependencies are required. So they will tell that they need PHP, they have to install in the system, or they need a Apache web server, they have to install PHP, they have to install in the system. Then only their application will work. The developer is developing application. This application will work in the system, and they will install the application, and they will give this up. They will make the application. This is the application they will create, and they will give this to the systems team. So the other team is responsible for creating server, and they will install the application. So the developer company, they need an application, they will develop it, and they will give it to the system or operation team. They will give it. So generally this problem will come. So this application, when you are downloading any application you install in your server, this will not work correctly, because here we are using Ubuntu. We are using, maybe I'm using Apache version. We are using some version. So we are using PHP, some version we are using, and they need so many dependencies they required. So they want to connect to a database, so they need some dependencies. So this application, when you install the same application in another server, so we are installing, this is my servers or some other place I am installing, application will not work. So the application is not going, sometimes it will not work, because of mainly the systems are different. Their dependencies or libraries, runtime, everything is different. Same, maybe they use different OS. So this problem they can solve. What they do, developer will create a they will in their developer, what they do, they will install the application in a container. They will create a container and they will install the application in the container with all its dependencies, libraries, everything. So they will create a container. So when they want to create a container, we know we need OS and we need Docker they installed. So using that you can create containers. So this container is having all the dependencies, everything is there in the container. So this container you can move to production server. In the production also, they will install this container engine. You can create the container here also they can create. So now this is that is called the containers are very much portable. So you can why we are using the container, because you can install the container and you can send it to another system. So what they do is they used to create a container. They will create a container, install the application, then you will create image. One minute. So that is the way it will work. So that is the way reason it is called containers. So we are going to show the demonstration how we are creating a lab and installing container. So as you can hear now, you are hearing. You can just give me some message if you are audible. Yeah, because I am just told the two things. One is container is like a virtualization. Or mainly virtualization means you have to install VMware or something you will install. Hypervisor means example is VMware. You will create and you will install it. You'll create VMs. Your laptop you can create a virtual machine using VMware or Oracle VirtualBox, Hyper-V, Linux KVM. All these are hypervisors. So here in the right side, third option is container. They use Docker engine. Container engine they will use. There are a lot of Docker engines. Container engines are there. Called we are using mainly container engine is Docker, but other engineer is other Docker other container engines are there like Rocket, Apache. They have their own. There are many are there, but mainly popular is Docker. So why we are using Docker? Because it is very portable. You can create a container, install your application, and after that you will make a package. You will make an image of that. You can move it to another system. So that is the way we are doing. So we are going to install steps. I am going to show now. Container Docker container we are going to create. Docker is a engine tool for creating containers. So container is similar to virtual machine. So now we have to. I created one Ubuntu. I created one Amazon Linux, and I am going to install container. So I am going to give this command yum install Docker. So what it will do, it will install, download and install the Docker software we are installing. Docker is a tool for creating the container, and we will start the container service Docker start we can create. And now we are going to do these two commands. I have one server. I am going to log into the server, and I am going to install container engine Docker. I am going to install in the server. I take the IP of my server. So I'm going to do a test session, and I am going to use my keys and all. I have to do it. So I am going to paste my IP. The key already I loaded here. I have saved it. So I am going to log in to the server. So this is a new server. I am logging. and we have to create your key, generate the key, all we have to do. So I just login. So I'm logging to my server. So I'm going to log in as a root user. I'm going to do sudo su hyphen I want to log in as a root user. So first command is I am giving yum install docker command. I am installing. So I'm installing docker. So I am installing docker. I am installing. So now I am going to start the service docker start. I am giving starting the docker service. So now I am going to create the container. So next step is I am going to download some image. So I'm going to download some image. For example, I want to download there are a lot of image. You want to download CentOS means you can download CentOS image. You can download Ubuntu means you can download full image. So image I am going to download now. So I am just today I am just downloading Nginx. It's a web server, Nginx. So I'm going to download one Nginx engine. I am downloading Nginx image. I am downloading. What is this image means? Pulling means I am downloading the image. What is this image means? We are going to create a container. So when you want, you have to know how to create one virtual machine. Now you want to create a virtual machine. Now you need CDs or ISO files you required for creating virtual machine. So you need a CD or ISO file of your operating system is required for creating virtual machine. But in the you can compare this in the container. You need a you are using some image for creating containers. So similarly, when you're in cloud, you use AMI to create the servers. So this way you are using images in here. So this images are we are downloading from a repository. So Docker they have their own repository called Docker Hub. So you can create our own account in the Docker Hub, and we can also upload your images. So we are going to download the images, or all the images we are downloading from this Docker Hub repository. So you can log in, you can just we can create our own account, free account, and we can otherwise public repository we can download everything ourselves. So the Docker Hub is a place where we are downloading all these images. So you can search for images. You want Ubuntu means they will show the image of Ubuntu. But today I am just downloading one. Docker pull. I am going to download one image called Nginx. So this image I am going to download in my system. Here we are doing locally, so that is the reason we are downloading. Cloud we are not downloading because that's all we are doing in the cloud. I have to download these images. You can check the images here, Docker images. So there is no image is not there. So I'm going to create a pull a image, downloading a image. Nginx means it is going to download one image. So you can download Nginx is a built-in server, web server, or I can download Linux, CentOS, Ubuntu, also Apache, Jenkins, all inbuilt. I can download. So I'm downloading this image. So just downloaded the image. So what I done is downloaded the image. So now I can see my Docker images command. So we can see that I have locally one image I downloaded. The image name is showing, size is showing. So the difference of here between virtual machine is here this image sizes and everything is coming in megabyte. So now we downloaded the image. So we are doing very few steps. So you are going to create one container. So you can create a container. Docker run -it means interactive, and we are doing -d means it is starting as a daemon process. I means interactive, so it will use some TTY shell or something, and D means daemon process. So it will work as a daemon process. So I'm going to create a container, and I can give a name. I can give, so the name of my container is, I can give a container1. So I'm going to create one container. I am going to create. So this is docker run is the main command for creating a container, and I can tell that what image I want to use. So I am going to create a image name is this nginx. This is the image name. This is the container name, and this is image means it is like our CD or ISO file. This is the container you are creating, and this name is the argument, and IT is options we are doing. And this container when we are creating, so it will create inside your inside our server. So we are going to create a container inside this system, but we want to connect this to this container from outside. So we know that this server we having a public IP will be the main system having a public IP. Oh, you can create this container in your cloud also. You can create in your own laptop virtual machine also. So this container will have its own IPs, everything, but public IP is also there. Container, if you log into the container and you can check your IP, there will be different IP will be there for this container. But somebody want to connect from outside my laptop. I want to connect to this container from my laptop. I want to connect to my container. So what I do? So I have to do some. They will do some port mapping. They are going to do from. I will connect to the container now. So this container, I created a Nginx container. So the container is working in a port number 80 because it is a web server. The container working in port number 80, and you can create multiple containers. And whenever I want, I can connect from outside also. I can connect. Maybe my server IP is we previously we saw the server IP. So the server IP may be like this 13 14 some IP. So if suppose I want to connect this my lab from my laptop, my computer. So I want to connect to my container. So because a lot all the containers may be using same port number. Internally they each container I use multiple containers. So every container use same port number. So outside what they do is they will do some port mapping. So they will tell that this port number 80 port number 81. I can just give 80 port number. It is mapping to first container. So they will give an external port number. So they are telling this is mapping to this container. And I can give another port number. I can map to second container. So I will give external port number 81. So this will be mapping to second container. So I will explain it one more time. But today what I am going to do, I am going to do this command. So I am going to do some port mapping also. Just understand this is my external port and this is my internal port. So this is my container port, and from outside I want to access, I can give this port number 80 or 81 or anything I can give. So I am going to run this command. So docker, this is the command we have to remember. So docker run is creating a container interactive shell, and name is this, and the port number we are giving. I'm going to copy this command and execute it. What it is going to do is it is going to create a container. So I downloaded image and I'm going to execute this. So I am going to I installed I'm just opening this stand out. So now I am going to give this command. So what is this command is doing? It is creating a container. Before doing this, I will show another command, docker ps. Docker ps will show all the running containers, how many containers are created, all running containers. Docker ps -a means it will show all the containers, stopped container and started containers. PS means listing of the containers. So I am going to give this command. So what this command is doing, it will be creating a container with a name of and a container one, and the image I am using is Nginx. So it is created a container now. So now I do docker ps means it will show that container is created, container is working. So now I have one container, it is having Nginx software is installed. So now I will take the IP of my server and I will paste that IP here in my browser. So you can see that there is an inbuilt web server is working inside the container. So this is working inside the container now. So I can create one more container if I want. I can create it. What I have to do, I can create any number of containers I can create like this. So we downloaded one image and created the container I created. So Docker PS is showing. So now I can log into that container. So now currently we can see I am in the original machine, host machine. Inside this, I created small containers. I created one container I created. So I can log into the container docker exec -it. My container name is container1. So this command I will container1 I am going to do. I am going to open a bash shell in the container. So this command will going to log in inside the container. So when we generally when Linux server and all we will do putty session and SSH we will do. Like this container you want to log in, you want to go inside your container, you can give docker exec command to log in inside the container. So I'm going to copy this command. So now you can check your prompt now. So currently the prompt is IP address, but when I do this command, it will log in inside the container. So you can see the port is this is changed now. So now I am inside my container now. And I can see my file system everything here. So it is showing so many files everything. But now I have to know I am inside the container. I am not in the original system now. So now if suppose I created some files, touch 111 or something I created. So you can see it is I am in the root file system now. I can see all my bin, all my files are there. But I have some file 111 or something I created. But this is inside the container. It is if I do cd/ and when I do ls, I can see my files. But I am inside my container only now. But when I do exit means I will come out from the container. When I do exit, I will log out from the container. So now I am in the original machine. So when I do cd/ and I can check my file system. So this is a entirely different file system. This is my original computer's file system, and this IPs and the container also having a different IP. I will explain. So now I am going to log into the container again. Docker exec it container bash. I am going to log in inside the container now. So now we can do ls. I will see some files I created 111 and all I am seeing. So because the container is installed, so there is my home directory of the Nginx server is user share Nginx folder HTML. So their HTML file they are storing in this directory, user share Nginx HTML directory. They are storing HTML files. So this file I can change it. So this file I can change to, I can create my own index page I can create. VI is not there. So I am going to create my own file. So cat greater than, and I want to create my own HTML file I want to create. I'm going to create an index.html file. So I'm going to copy some files. So just taking some HTML file I'm creating inside this. So I'm going to create using cat or something. I'm creating this file I'm creating. And if I am giving enter, I am giving control D. So otherwise I can edit this file. So I am inside the container. VA editor, everything is not installed. I have to install it. I am telling that this is container one. So without vi, I want to create file means I have to use cat and I have to save this content. Control D will save the file. So I created one new index.page I created. Now I check my IP address and I will refresh it. You can see that my HTML page I changed. So this is a very basic. So I logged into the container and I changed my HTML file. So we are going to do everything from beginning. We are going to create a new Linux container. We'll create tomorrow. We'll install everything. We'll do. So now I'm doing exit means I'm coming out from the container. So docker ps means it will show container is working. So now what we did, so same like I explained you. So I just created a container and installed application container. So container I used, I created a container and I using a nginx image. Like your Amazon, you are having image. So using here we have nginx image. So now what I did is I installed the application. So I don't install the application. I installed some HTML file I created. So we have to generally will install application, or here I created my page, HTML page I created. So now we are going to create the image of the container now. Creating the image we are going to create. So next is we can create the image of the container. So I just logged into the container and I went to this directory user share and nginx HTML, and I created one index.html file I created. So type something and just type something welcome or something you type. So then you have to do Control D. So now next is I am going to create I can create a image of the container also I can create. So what I will do, we can create now. What is the next step I am going to do is I will create an image of the container I am going to create, and I can upload it to Docker. I am going to upload Docker Hub. I can upload it. So that all I can do. So you have got some idea, Devendra, how what is container? Some basic idea. So you have some questions. So we have to know this basic commands. First command is we are installing Docker engine. We are installing. It's a engine we are installing, and service Docker we are starting. The Docker process service we are starting. Docker is an engine for creating the containers, and we are downloading the image. Engine's image we are downloading, and you can check your Docker images command. We can check it. So it will be showing the images. Only one image downloaded. So we download any other image. You will create Ubuntu and OS. So many things you will create. So many images you can download. What it is doing? It is going to create a container. The container name is this one. And port mapping everything I will explain. 1 week we will study about. 1 week we will study this. So and we are going to create a container using the image is this one. This is my container name. And now you can see Docker running container. You can see by Docker ps. Docker ps a-a means it will show the stopped container also. And here I am going to log into the container using this. So I will go inside the container. So and I went inside the container, I can install application. I did not install it, but you can, we will install tomorrow, we'll install some application inside the container. And we can check the IP address. So we can see that we are installed some HTML file and all we installed in this. So now I am going to create a image. I'm going to create what I am command I'm giving is docker commit. So now I am going to create a image using a next command is docker commit. So my container name is container1. So the new image I am going to use as image. I'm going to give a new image. Just this is the name of the image I am going to give. So I already created all the application. So now I want to create an image. Then only I can move this to another system. So I am going to create my own image. I want to create. I'm going to create an image. This image you can move to another systems. Similar to how you are creating image in AWS and all you are creating. So this containers image I want to create again. So that is the reason I am going to give this command docker commit. So I can check the images now. Docker images only I downloaded one image that is there, but docker ps means I know one container is running. Container name is container1. So now I am going to give this command docker commit means it is creating an image from the container, and the image name is this one. I'm going to give now. So what it is done, it is created one image. So now I have two images. I have docker images. I have new image also. I am having downloaded image also there. So what is there is extra in new image. I downloaded the Nginx image and I copied my own HTML page or application. I copied it inside the container. From the container I created the image again. Now I can create new containers. Docker run -it-d and container name I can give as container2. And I have to give a different port mapping. I have to give the external port is 81 and internal port is 80, and the image I am using is new image. So I am going to create a new container2 using the new image, but the external port I given as new image, port 81. So now I created a second container. I created docker ps. We can see that new container is working, but this container is working in the another port number. So I can check this address, but the port number I am changing to :81. So you can see that the IP I am giving the same, but the port number I am giving :81 here. So this also will have the same copy of my server. So I can just copy and paste here. This is my copy of my previous server. This is the second container. The first container I am opening again but the port number is 80. 80 is a default port. Without 80 also I am giving. First container is this. I can see that this is the container one I am getting. Second container I am using port number 81. So okay, I will be telling an overview about container. So if you have doubt means tomorrow I will explain again.
Okay,
So
sure.
you can just practice this.
I will practice it and study about this. What is the Docker and how we can implement and where